Hello everyone, my name is Wachirawit Chaifongsri. Today, I'm gonna tell you about my favorite math topics that I'm very keen of in calculus course. That is the value of E. The reason of E that I love it is that uh, we know the fact that E is an irrational as well. Now, let's begin the proof as well. Now we shall begin. The reason that I'm very keen of the proof of a rational liberty of value E is that I really like this equality as well. To begin the proof, I will prove lemma A firstly. You see that I denote Sn is the summation of uh, 1 over 2i factorial sum together for the first integer, where n is in the set of natural number as well. So moving to the lemma A, you see that we can show that 0 is less than the value E log Sn and less than 1 over 2 n times n factorial for every natural number n. So I will first fix the value n and let n be an integer that is greater or equal to n plus 1. Then we observe that Sm minus Sn is equal to 1 over 2 n plus 1 factorial. And then you plus until to the 1 over to the n factorial. And I actually use the equality that for each n plus k must be greater than n plus 1 for every k is greater than or equal to 2. That means that we can obtain the equality like this. Now, I will factor 1 over 2 n plus 1 factorial. And hence we can obtain the equality like this. We know the fact that this finite summation also less than the infinite summation 1 plus 1 over 1 plus 1, and then you plus until to the infinity. That's converge to this value as well. And hence we can obtain this inequality, which is also depends on the value of n. And following that, I will take limit of m when m approach to the infinity. We know that this summation are by Taylor series. That means E is equal to summation 1 and 1 over 2 factorial, and then we plus until to the infinity. And hence we can obtain such equality as well. Now, we get the precise and beautiful inequality that I'm breaking off. So the main goal is that I will show you that it is an irrational number. I know that for this proof, I shall show you by a contradiction. Now I will suppose that now I suppose that E can written as P over Q when V is is an integer and Q is a natural number. Hence, we obtain that Q times E is equal to P is an integer as well. When we know that this equality for holds for every integer n, I will put n is equal to Q. So we obtain 0 less than equal E minus SQ less than 1 over 2q times q factorials and I times q's factorial both sides of the equality. Thus, we obtain 0 less than q factorial times e minus q factorial times sq and less than 1 over q. From the fact that q times e is an integer, we obtain that q's factorial times e must be integer as well. In addition, sorry, my bad. In addition, we know that, just a moment please. We know that q factorials times sq is equal to q factorials times 1 plus 1 over 2 factorial plus until 1 over 2q factorial. That's when you simplify this summation, it also be an integer that way. Thus, we get q factorials times e minus sn is an integer between 0 and 1. 0 and 1 over 2q, which we obtain a contradiction. That means that E must be an irrational number. You see that? This is my favorite topics because I bear in mind that when I had studied at the second year in the advanced calculus, this is the bonus problem that I can do in the midterm examination. So I did try hard to study the reason how that is born and learn the way that how the beautiful equality is by using some elementary of calculus and also use some pure mathematics like logical and reasoning. And that's how I think my goal is an irrational number is my favorite and inspirational theorem that I wanna tell you for my interview as well. And now, that is the end of presentation. Thank you for your attention and take care of yourself due to the COVID-19 pandemic.